Assalamu alaikum. Today we will start exercise 3.5a from chapter number 3 of IGCSE Extended Mathematics that is recommended by AQA examinations. Our topic is polygon angles. So as we already discussed in our previous exercise that polygon is the shape that has many sides, and we were discussing the interior and exterior angles. So let's start question number 1. In question number 1, it says a regular polygon has acute interior angles and we have to name the shape. Basically, we know the formula to find the interior angles. The sum of interior angles can be found by using this formula, which is n minus 2 times 180. But if we want to get the size of each angle, basically each interior angle, we can use the same formula, but we can divide by n, means number of sides. So here we want to have acute interior angles, means all angles should be less than 90 degrees. So we can just see that what will be the size of each angle in three-sided shape, means three-sided regular shape, means it will be a triangle basically. So we can just put 3 over here. So it will be 3 minus 2 times 180 divided by 3, and that will be 60 degrees. But as we just replace n with 4, means four-sided shape, all angles will become equals to 90 degrees. That will not be the required answer. So we will write the name of the shape, and that should be equilateral triangle, which is actually a regular triangle. All angles will be less than 90. So all angles will be acute interior angles. Let's proceed to next question. In question number 2, it says the diagram shows a part of the regular polygon, and like each interior angle size is mentioned over here, which is 162 degrees, and we have to calculate the number of sides of the polygon. So we know the formula, which is sum of interior angles should be equals to n minus 2 times 180 degrees. We can change this formula a bit, like sum of interior angles can also be found by multiplying the number of sides with the size of each angle. So we did a bit changing in this formula, and we rewrite the sum of interior angles as n times the size of each angle. That is satisfying the situation. So we have to find the number of sides here, means we have to find n, and we know the size of each angle, which is 162. So if we just replace the size of each angle, which is 162 degrees, we will get the equation like this, and that will be 162n equals 180n minus 360 degrees. On the right side, we just expanded it. Let's solve it. So we'll bring 360 degrees over here and 162 on the other side, and we will subtract it. And that will be 18n over here. Now let's divide both sides by 18 to get the size of n. So n means number of sides will be 360 divided by 18, and that will be 20 over here. It means the shape has 20 sides. So n will be equals to 20. Now let's proceed to next question. In question number 3, again, they want us to find the number of sides if the size of each interior angle is 177 degrees. So we can again use the same strategy that the sum of interior angles will be equals to n minus 2 times 180, but we did some changings, like we represented sum of interior angles as the size of each angle times the number of sides. So we can simply put the size of each angle, which is 177. So it will be 177n equals 180n minus 360. We can expand it. Now let's bring constants on left side and the variables on the right side. So we'll subtract 177n from 180n, and that will be 3n. So let's divide both sides by 3. So we will get the size of n as 120. It means there are 120 sides where each interior angle is 177 degrees. So the number of sides are 120. In question number 4, it says a regular polygon can be made by fitting together squares and regular hexagons. How many sides does it have? So first of all, we have to imagine the regular polygon that is made when we join these together, these squares and regular hexagons. So let's imagine. So this is the shape that we will get if we keep joining these hexagons and squares. So inside these shapes, there is a regular polygon. Now to find the number of sides, we need to find the size of each interior angle. We can use this formula that the sum can be written as n times the size of each angle equal n minus 2 times 180 degrees. So let's first find the size of each angle. So we need to do some constructions over here. Let me name some points like A, O, and B. These are the three vertices where you can see at O, it's the joining point of the vertex of square and hexagon. Now I will extend this O to X. And you can see that this line is basically the extension of the side of the square. So there is a right angle over here, means it's 90 degrees. Now to find the size of interior angle over here, we need to find this remaining size that I represented by red color, and it is basically the angle AOX. To find AOX, let's consider this straight line over here. On a straight line, we know that the sum of angles should be 180. So first we need to find the interior angle of the hexagon. So the size of each interior angle of the hexagon, if we work out for that, we can use this formula that size of interior angle of hexagon will be equals to 6 take away 2 times 180 divided by 6, and that will be 120 degrees. It means this remaining size AOX, so the angle AOX will be equals to 180 minus 120 degrees, and that will be 60 degrees. So the size of AOX is 60 degrees. It means the size of the interior angle of the polygon will be the sum of AOX and angle XOB, which is already found, means which is 90 degrees. So the sum of 60 and 90 will be 150 degrees. Now let's proceed to find the number of sides if each angle size is 150 degrees. So we will again use this formula over here. We need to find the number of sides, and the size of each angle is 150 degrees equals, if we expand the right side, it will be 880n minus 360 degrees. Now let's calculate it. It will be 150n equals 180 n minus 360. Let's bring 360 over here and 180, take away 150n. We are solving the variables, and I just got 360 on the left side. Here I need to subtract, so this should be 30n and 360. So to find n, I will divide both sides by 30. So the value of n will be equals to 12. It means there will be 12 sides of the polygon that we will get by joining these hexagons and squares. Now let's proceed to next question. In question number 5, it says a regular polygon can be made by fitting together squares and regular pentagons in alternating pattern. How many sides does it have? We have to do the same thing over here, means we have to imagine the shape, or means the polygon that we get after joining the squares and regular pentagon. So let's see the shape. This will be the shape that we will get after joining alternating pentagons and squares. So we have to do the same thing, means we have to find the size of interior angle. So let's again draw a line, which is basically the perpendicular side. We are extending the perpendicular side of the square. We can see there is a right angle over here. We can call this point as O. We can call this point as A and this point as B. And let's call this point as X. So XOB is 90 degrees. And we have to just find AOX. Basically, the sum of AOX and XOB will be the size of interior angle of this polygon. So to find AOX, we first need to find the size of interior angle of the pentagon, because there is a straight line over here, and then we can subtract the size of this interior angle from 180 to get the size of AOX. So the size of each interior angle in the pentagon will be equal to 5 take away 2 times 180 divided by 5, and that will be 108 degrees. It means the size of angle AOX will be equals to 180 minus 108 degrees, and that will be 72 degrees. Now the size of each interior angle in polygon will be equals to the sum of angle AOX and angle XOB. AOX is 72 degrees and XOB is 90 degrees. So the sum is 162 degrees. Now we have to find the number of sides if the size of each angle is 162 degrees. So let's do some working over here. We can do this working inside this polygon. We can use the same formula, means n times the size of each angle will be equals to n minus 2 times 180. We know the size of each angle is 162, so we'll get 162n over here, and on the right side I can expand it to get 180n minus 360 degrees. Let's bring constants on one side and variables on the other side. Let's take away 162 from 180, and that will be 18n. And if we divide 360 by 18, we will get 20. Means there will be 20 sides if the size of each interior angle of the polygon is 162 degrees. So we can write n will be equals to 20 degrees. Let's proceed to next question. In question number 6, the diagram shows a regular hexagon attached to a square. We have to calculate the angle z, and we also have to name one or more regular polygons that would fit exactly into this space. So let's first find the size of z. Again, we can extend the side of the square, which is actually perpendicular side, so that can give us 90 degrees at this point. This is 90 degrees. We just need to find this remaining size, and for this remaining size we can consider a straight line over here, and first we need to find the size of interior angle of hexagon. As we already worked out for the size of each interior angle in hexagon, we know that this size will be 120 degrees. So this remaining size should be 60 degrees over here. So z is the sum of these two angles, so z should be 150 degrees. Now we need to work out for the part B. Basically, we have to name one or more regular polygons that would fit exactly into this space. So we need to actually find that how many sides would there be if the size of each interior angle is 150 degrees, and then we can fit the polygon over here. So let's work out for the number of sides if each side will be 150 degrees. So we can write the formula that n times the size of each angle, each interior angle, can be found as n minus 2 times 180. We know that the size of each angle should be 150 degrees, and we are looking for the number of sides, so it should be 150n equals 180n minus 360 degrees. Let's bring constants on the left side and variables on the right side. If we subtract, we get 30n, and if we divide both sides by 30, we get the number of sides as 12. It means 12-sided polygon can be fit in this scenario. So the 12-sided shape is also called dodecagon. So this shape can be fit into this size. Now let's proceed to next question. In question number 4, it says the interior angle of the regular polygon is 4 times the size of exterior angle. Let's consider exterior angle as x. And it says the interior angle is 4 times more. Then interior angle will be equal to 4 times x. And we know the sum of the interior and exterior angle will always be 180 degrees. So we can write the sum of x and 4x equals 180 degrees. If we solve it, we get 5x equals 180 degrees. And if we divide both sides by 5, we get 36 degrees. It means the size of exterior angle is 36 degrees, and the size of interior angle is 4 times the size of exterior angle, means 4 times x, and we know that x is 36, so 4 times 36 is 144 degrees. So now we have to find the number of sides of the polygon where the size of each interior angle is 144 degrees and the size of each exterior angle is 36 degrees. We know that the sum of exterior angles will always be equivalent to 360 degrees. And we can rewrite this that the sum of exterior angle can also be written as n times the size of each exterior angle equals to 360 degrees. And if each exterior angle is 36 degrees in size, so we can write 36n equals 360 degrees. To get the number of sides, we can divide both sides by 36, and that will be 10 over here. So its A part is solved, means the number of sides will be 10. And in B part, they want us to name the polygon, so definitely it's 10-sided shape, means it's decagon. Now let's proceed to next question. In question number 8, A part, it says, is it possible to have a regular polygon with a given angle as exterior angle? If so, find the number of sides. So as we already know that the sum of exterior angles will always be equivalent to 360 degrees. So we can rewrite this formula that the sum of exterior angles will be equal to, by the way, this formula can be written for only regular polygons, that the sum of exterior angles can also be written as n times the size of each exterior angle equals to 360 degrees. So if the size of each exterior angle is known, means 10 degrees, 9 degrees, 8 degrees, or 7 degrees, we can just substitute in the formula to get the number of sides. We can divide 360 by the size of each exterior angle. So first we can divide by 10, and we will get n as 36. So it will be 36-sided shape where the size of each exterior angle will be 10 degrees. Now let's work out for the second part, means 9 degrees. So if the size of each exterior angle is 9 degrees, we can divide 360 by 9 and we will get 40 over here, means it will be 40-sided shape. Now for the third case where n is 8, so let's divide 360 by 8 and it will be n equals 45, means there will be 45-sided shape. In fourth case, where the size of each exterior angle is 7 degrees, so we can divide 360 by 7 and we will get, this time we are getting a decimal number like this. So by the way, the sum of all exterior angles should be equally divided by the number of sides. So the fourth case is not possible because here the 360 degrees cannot be equally divided amongst 7 sides. So it's not possible that it's a regular polygon. It's not a regular polygon. Now let's work out for part B. Write down a general rule to describe when a regular polygon with a given exterior angle is possible. So we can write the general rule that if 360 is being divided by the size of each exterior angle and it gives a whole integer value that is equals to or more than 3, then the polygon exists with n sides. Or we can also write that the exterior angle must be a factor of 360 degrees. Now let's proceed to next question. In question number 9, we are given with a regular pentagon PQRST. I have provided the shape, and we have to prove that PS is parallel to QR. So PS is this line that joins the points or vertices P and S, and QR is basically the side of the pentagon. So we have to prove these two lines are parallel. To prove, we can draw a transversal, and if it is a transversal on the parallel line, then the angles means these two interior angles must be added up to 180 degrees. And then we can easily write that these two sides are parallel or lines are parallel because the adjacent angles are added up to 180 degrees. Or we can also call these angles as interior angles. Let's work out for the size of angle Q. And angle Q is basically the interior angle of the pentagon. So we know that the interior angle of the pentagon can be found by using this formula. Interior angle equals to n minus 2 times 180 degrees divided by n. We know that in regular pentagon there are 5 equal sides, so 5 minus 2 times 180 divided by 5, and that will be 108 degrees. It means the angle over here is 108 degrees. Now we have to work out for the angle at this point, which is marked, which is drawn with a green color. So to find this angle, let's first consider a triangle PTS. And in this triangle, we can see that there is again an interior angle which should have a size 108 degrees. And this triangle has two equal sides, means this is an isosceles triangle where the base angles, let's call these base angles as x, these two base angles should be equal in size. And again, the angle at P will again be the interior angle, means the angle at P will be the sum of the angle which is marked by green color and x. So let's find the size of x first. So we will consider this triangle over here. So in triangle PTS, the sum of x and angle x and 108 degrees is equivalent to 180 degrees. It will be 2 times angle x plus 108 degrees equals 180 degrees. To find the size of x, we can first subtract 108 from 180, and then we can divide by 2. And that will be 36 degrees. So we have found the value of x, which is 36 degrees. Now to find the size of angle at P, which is shown with a green color. So this angle can be called as angle SPQ. And this angle is basically the difference of the interior angle, which is 108 degrees, and the size of x. X is just found, which is 36 degrees. So we can write 108 minus 36 degrees, and that will be 72 degrees. So look, if we add these two angles, means angle Q and angle SPQ, which is 108 plus 72 degrees, we are getting 180 degrees. So we can finally conclude that since the angle Q and angle SPQ makes 180 degrees and these two are interior angles, then the lines which are making these two angles should be parallel. So we can conclude this and we can write this, but let me first bring this working on the top. So we can mention that since the sum of two adjacent angles or interior angles or allied angles means angle Q and angle SPQ is equivalent to 180 degrees. So the lines which are making these angles should be parallel. So PS is parallel to QR. Now let's proceed to next question. In question number 10, it says A, B, C, D, E, F, G, H is a regular octagon, and we have to prove that ACEG is the square. So ACEG are basically the alternate vertices of the regular octagon which are joined to get a square. So to figure out, to prove that ACEG is a square, we need to do some constructions. Means first we can consider these angles. So look, that angle F is basically the interior angle of the octagon, and the size of each interior angle of the octagon should be equals to n minus 2 times 180 divided by n. And we can easily figure out that by substituting n as 8, that will be 135 degrees. If the size of angle at F is 135 degrees, and if we carefully observe here that the side FE and GF are equal in length because these two sides are the sides of regular octagon, means these two base angles should be equal in size. Let's call these base angles as x. Now to work out for the size of x, we will consider an isosceles triangle which is GFE. And here the sum of all angles should be 180. So we can write angle x and 135 equals 180. To work out the size of x, we can write 2 times angle x plus 135 equals 180. Let's subtract 135 from 180 first, and that will be 45 degrees. So if we divide both sides by 2, we get the size of x as 22.5 degrees. Now we can also consider the triangle CDE as another isosceles triangle, where this angle will also be equals to 22.5 degrees because this is the congruent triangle, means it's again has two equal sides, means it is an isosceles triangle, so its base angle will also be 22.5 degrees. Now we need to observe the interior angle of the octagon over here. Look, the interior angle of the octagon at E should be equals to 135. Now we can easily work out for the angle GFC. So for the angle GFC, we can subtract the given angles from 135 because the size of each interior angle is 135, and we can subtract two equal angles, means 22.5 and 22.5. In total, these are 45 degrees. So let's subtract 45 degrees from 135, and that will be 90 degrees. So we have proved that the angle at GEC is 90 degrees. So similarly, we can also prove that these angles means ECA and CAG and AGE will also be 90 degrees in size. Since all interior angles are 90 degrees in size, means angle GEC and angle ECA and angle CAG and angle AGE are all equal in size, means 90 degrees, and sides AB, AG and GE and EC and CA are also equal because these are the corresponding sides of the congruent isosceles triangles. So we can say that ACEG is the square. So basically we have proved all interior angles of the square equivalent to 90 degrees and all sides ACEG are equal in size because these are the corresponding sides of the isosceles triangles. So ACEG must be a square.